Hi, everyone. I think today we will give the talk about using the PPR and how to using the PPR to simplify the observability queries. Today, I will work with my colleague, Ashwin. He is a maintainer of the OpenSearch dashboard, and I'm Peng. I'm the maintainer of the OpenSearch PPR and the SQL. In today's talk, we will cover about a couple sections. Firstly, we want to discuss what's the problem, why we need the OpenSearch PPR, and what is OpenSearch PPR for, and what's the problem is solved. And we want to go over the PPR language in high level and give you an introduction of that. And then we will discuss some high-level PPR features, command functions. Then we will discuss the future or roadmap, what we are doing and what is in plan. And at the end, as Ashwin will give an awesome demo of how to using PPR in discovery with visualization and add to the dashboard. It's all live demo. Yeah, I think we can get started. We start from the problem. So what problem we're trying to solve? In today's observability landscape, teams is struggling with how to write the query, to query the log data, query the trace data. There are different DSL. All the queries have their own syntax, have their learning curve, have their own grammar, function names. It's very hard to remember them and know what you should use. For example, thinking the case, if you store the log in the OpenSearch, you need to using the OpenSearch DSL to query your data. If you have the log in your CloudWatch, you need to using CloudWatch Insights query. Or in some cases, you also have your log in S3. You need to using Athena SQL, Presto SQL, or Spark SQL to query your log data. And all these queries is inconsistent and not portable. You're using one query in one system, but you cannot using the same query in the other system. And the other thing is drawing the incident analysis. What you want to focus on is find the root cause, but not debug your queries. If the query itself is complex, it will slow down. You need to spend more time on the query debug instead of the real problem you're trying to solve. So before I jump into how the PPR solve the problem, I may ask bring one real problem. Thinking that's real use case, you want to bucket your event by the time and aggregate the metrics in series, with the limit capping how many series you want to show and merging all other remaining categories in other bucket. So I just show the result in here. So actually, it just group by the data set by one day and capping by top 5 APIs and calculate the count. So maybe I can give 10 seconds. You can think of if you're using SQL or whatever familiar language you are using, how can you can write the SQL queries? How many join or how many functions you will use to compose that result? Anyone have any idea? How many join queries you will use for compose that result? Sure, maybe I can go to the real SQL query. So on the left is a SQL query you can use to compose that result. It includes the join, left join, union, case function, also some where clause. So it's almost over 30 lines. I already simplify them. It will be longer. But you compare with the PPR query we are using, it's just one line or 2 lines. So actually using 2 commands. I want to search my source data, and I want to do the time chart. I want to group by the API field. I want to count. I only want to limit the file, no others. So using this PPR query, the major benefit we can get is, let me go back. It's easily to manipulate that query. It's very, like a human language. It's very interesting. You talk with the system. Let's thinking if you want to where condition, how difficult you add this where clause in that complex SQL query include the multiple joins. But in the PPR query, you just add the where command. This very easily. So when we design the PPR query, we keep in mind is we want to borrow from the Unix pipe style. And actually, PPL query is read-only search, consisting of the series of the command and delimited by the pipe. So let's take one example. Kindly, it's just like you speak the plain English. I want to search the error and the 404 in all my logs index start from log. And then I want to do is I want to do the time chart and span by 1 day timestamp and count the request count by the attributes URL path. This helps us to build the visualization, build the dashboard. So in this PPL query, I actually include 2 PPL commands, search and time chart. This is the command in PPL. Also, it supports the full tag search. You can search the error and the 404 in all your logs. This is the vanilla OpenSearch index feature. And in the PPL, actually, we're compatible with OpenTelemetry grammar syntax. We support all the OpenTelemetry fields. In this example, actually, your attributes URL path is one standard OpenTelemetry field name. So actually, we started the journey from years ago. At the beginning, we only focused on some simple search and the transformation in the PPL. And after the OpenSearch 3.0, PPL is powered by the call set. And currently, we already support the 38 commands and 173 functions in the PPL in total. So I want to bring some important command. That's not cover all, but want to give you guys some high-level idea how you compose the PPL query, what's the mental model you should follow. All the PPL command is start from the search command. The meaning of the search command is you want to filter on your data and leveraging the Lucene index, OpenSearch index. What you can do is you can do the full tag search. You can do the key value comparison in the search command. After the search command, your search space is dramatically reduced. You can only focus on the event you focus on. And after the search command, you usually want to do some processing. You want to derive some field from the existing field. That's the evaluate command will help you. You can do the mathematical calculation. You can get a new field from the existing field. And also, if you want to rename some field to some human-readable format, you can use rename command. And also, using fields command, you can trim down the field you don't care about. You only focus on some field you really care about. And some other powerful functionality of the PPL is you can do the processing of the text at the query time. You can extract the pattern using the regex pattern, using the JSON path, and also using the grox pattern. You don't need to do all the things at the query time. You can do it at query time. Also, we also support the sort and the dedupe to let you manipulate your data, sort in any order you want. After you're pre-processing your data, you want to do the aggregation. So in the PPL, we support multiple commands to help you build your visualization. So the first command actually is a time chart I just showed. Actually, it helps you to build the time series data analysis and build the visualization. Also, we support the standard status command. It's an aggregation. You can do the normal aggregation function you want. Also, the powerful event states command is very similar to the SQL window function. You can do the aggregation event by event. Also, in the PPL, we bring in the join capability. You can join the dimension table with your event table, with lookup, with join, and also with subsearch. It serves different purpose. For example, usually people will do the left join of their event table with dimension table. So lookup definitely is one command you are looking for. So in the PPL, we support a amount of the functions. Some powerful aggregation function I want to call it is actually count evaluation. It's very similar to the SQL count if function. You can build a visualization at the aggregation stage. You can filter different dimensions and do the aggregation. And also, we support the time traverse of your data set easily. You can using span function to specify which field and what dimension you want to group on. And also using earliest and the latest to traverse your data set using the timestamp field. Also, we support a lot of string function and the numerical function. So actually, PPL grammar is working perfectly with the OpenTelemetry grammar syntax. We support all the default field OpenTelemetry already use, span ID, trace ID, all the things. So architecture-wise, we follow the standard engine implementation. We have the parser, AST, and then eventually translate to logical plan. And we reuse the call-side planning and the optimizer to optimize our query. And then efficiently push down to the OpenSearch to get the performance. So let's quickly talk about our roadmap in the future. So we closely work on the CNCF query work group to align with them to bring all their standard functionality, standard query statement into the PPL. So in the future, PPL will align with fully compatible with the CNCF query work group to support the standard query. And beyond that, we also think we don't want to limit the PPL capability only for the OpenSearch. We want to extend that capability for all other query engines. So currently, we keep working on bring the PPL to the Spark. So you can imagine, you're using the same PPL syntax, you're using the same semantic, you get exactly query result across different query engines, across different data sets, no matter it's on S3, no matter it's on CloudWatch, no matter it's on OpenSearch. You get exactly the same thing. You don't need to worry about share your queries. So for doing that, we also built the compliance test suite. This suite to help us to guarantee that in the future, the query engine or all the PPL work can even work on or maybe Presto or other query engines. Yeah. At the end, I left some resource. Currently, everything is open source. You can find our repo, and you can also find our reference doc, which include all the commands, all the functions, all the data type, also some limitation of the OpenSearch PPL. So we also have the blocks shared, which introduce how we're using the PPL to power the lookup and the join feature and the subsearch feature in OpenSearch. So in the next section, I will transition to the Ashwin. Ashwin will give us an awesome demo about how to using the PPL in the observability solution in the discovery and build the visualization and dashboard.
Thanks, Peng.
Yeah.
Right. Yeah. Thanks to Peng for that nice talk about like the what and the why of PPL. Now let me give you a quick glimpse of like how do you actually use PPL for the demo. Oh, it does not automatically escape that. There we go. All right. So now that you guys can see me, let me actually start from OpenSearch dashboards, how you as a user would come and use it. And I'm going to go through a demo scenario, and hopefully the demo gods will be good with us today. And I'm going to be showcasing an example of a company, an e-commerce company. And in that e-commerce company, I'm a part of the checkout team. And so I have to now basically analyze the data from the logs that we have at checkout and come up with a dashboard that we can use for daily ops monitoring for what actually matters to my team. So before PPL, this was a lot more complex. You had to go through a lot more pages and write different queries, different visualization tools. People have used OpenSearch dashboards before, or others would have seen that's kind of the scenario. Now, all you got to do is go to Discover, and you're greeted with a new UI that we have built that lets me select from my usual multiple data sources. And let's see. So normally when I come into a screen like this, I don't know where to start, right? Like the big problem you have is like, hey, it's a needle in a haystack problem I have to solve for. Where do I start looking for? So I know somebody told me that, hey, there's a field called path, which is where the checkout APIs usually lies. So let me just quickly search for path. And I can quickly see that, oh yeah, the API checkout is right there. So just by clicking on that, automatically my query is updated, right? And if I do that, I'm now filtered down to just the checkout service APIs. Now, at the same time, I can also quickly glance through all of my, let me collapse that, all my different fields and what data I have in here. Now, sometimes, even this writing PPL may be a little difficult for simple scenarios that we want to do. So we actually now also have an AI mode directly inside OpenSearch dashboards Discover, where I can type text and get PPL out of it. A scenario is, show me the, let me see, request. Let's say OS name for the, let's see, why is that coming up here? Sorry? For the, I want, so another thing we realized is like when you actually have to type, okay, I have to, let me remind myself later. All right, that will, okay, so show me the attributes, and yeah, sometimes, AI is also not very good, it hallucinates a lot, so we actually added autocomplete into AI mode as well. So I can say like, hey, I want where the path only matches the checkout, right? So now, this is a fairly easy query to write yourself, but I don't even want to bother doing that. I just want to quickly ask, say, hey, show me all of the, what did I get over here? Okay, so turns out I don't have OS field name inside this. Picked a bad field, but you can see like it's automatically created a PPL that gives me this. Probably instead of resource name, let me take agent. Yeah, user agent. That's probably better, right? Okay, so let's see. Oh, I have user agent this. If I click on the visualization tab, I can see, oh, show me the, let's see, go back here. Show me the count for the path. So now I can see, okay, I have only one user agent with a count of 81 requests on that. I also may just want to quickly summarize the data that I've just gotten. So I can say, hey, show me what the summary of this data that I have looks like. And in the meantime, while that's rendering, I can also switch to a bar chart and see the same data that I wanted to see as a bar chart inside Discover. So this is a basic use case of how I would want to use AI for generating my queries. But this is, PPL is way more powerful than just this. So Peng, my teammate, has actually made a query that he's asked me to use if I'm going to do a checkout service-based, or just in general, I want to see statistics about network requests on my service. So he says, hey, go check the envoy stats query, and that should give you a distribution of all of the different error codes by request. So I'm actually going to switch data over here because now I'm going to go to the bleeding edge of what the calcite engine that Peng was talking about, where we have all of the newer commands all running. Okay, so rerunning that same query over here. Run that. Oh, I didn't change the data set, my bad. There we go. All right, so now you can see that I have 2,200 requests, and all of them are 2xx, which is nice. But you don't always have a nice query like this given to you, and you probably have to construct it myself. And I'm here to show you quickly how that's not that hard anymore with PPL and the nice experience we built around the language. So how do we go about building something very similar to this? So you would come in and you'd say, hey, I know that I have to filter by the checkout service first, because I know that's what I want. I also know that I want to get the log group to only say the envoy logs, because that's the one I want to see where the 200, 300 requests are coming from. And now let's see what this shows up. And I'm like, OK, I see some data, didn't really filter as much as I wanted to. But what I really want to see is a distribution of the status codes, right? So do I actually have a field called status codes in my request, in my data? Looks like that's not been parsed out as a separate entity. But I do see something good, which is like I can see here in my raw logs, there is HTTP1 200. So let me actually quickly just add this column as my default column. And I can see this pattern actually exists across all my logs. So that's promising, right? So now let me see, how can I parse out just that information and make it part of my data? So I can write parse, body, right? And then I'm going to write just regular regex over here. So I want it, oh, that's not actually how I would do it. What I would do is actually just copy the part I want to parse out right? I just take that. Like, hey, this is the common pattern I know, but this 200 is what I actually want to capture. So I make a new capture group. I call it status. And then I know these are all digits, so I can say D plus. Right? And now, can I see if it's there? Status, I see it's a field, 200. So we extracted out one field. Nice. Now, I don't want just 200 because it can come 200, 201, 202. Like there are multiple codes that these come in. So I want to bucket them all into 2xx, 3xx, 4xx, something like that. So how would I do that? Now I extend that and I say eval. And I want to evaluate the response of this. And I want to evaluate status 2xx is equal to if the status is greater than or equal to 200 and status is less than 300, make it 1 or else 0. And you could put any way you want to categorize this to do that. So let's see now.
You misspelled the status.
Oh.
Just misspell that.
Oh, shoot, that's why. STD-US, there we go. Awesome. So yeah, status. So that's 200, and then here's the state as well, parsed and evaluated. So similarly, I can just quickly copy this over, and I'll say status other, and this is just anything greater than or equal to 300. I don't need another condition here. And similarly, I have my status other. Right? And now, but again, this is just, I've still parsed out. Now I actually want to make a visualization, and I want to see the table that you saw earlier. So now I just do statistics on top of this, right? Stats, count, and then I want to see a sum of the status to XX. Let's see. There we go. So we've now constructed the same table we had before, and now I can visualize this as a bar chart or any other chart type that I want. But now you can see how it's not that difficult to make queries and make very complex investigations into your logs by actually writing out the PPL. Autocomplete, AI, and other things really take you very far. And now I'm going to quickly show you some of the visualizations you can actually create, because one part is actually extracting the logs out and creating, rendering the data, but actually visualizing them is where the power really lies. So we've actually built visualization capabilities directly into OpenSearch dashboards. And here's some queries that we have. So I want to see all the problematic clients that I have for my checkout service, right? So you can see I've parsed out all of the HTTP status again. I've removed all the null source addresses. And then I've said, just give me a count. And I've topped up the top 200 results. And I see that for 200, there are just 2 clients. But for 300, there's this 1 client. So I can quickly see visualizations like this. Let me show you another one. This is for a heat map, because sometimes I want to see, for a client ID, what would be the distribution of error codes. Wait, that was a different query? Yeah. So here you can see, I can switch chart types. I have a lot of controls of what I can build and control over here. And then I can also just easily quickly add to the dashboard. I don't actually have to go, if you've used Discover or dashboards before, you know how annoying it was to actually create a visualization or create a search like this, then go to another tab, go to your visualization. So all I got to do now is pick checkout service monitoring, for example, and say heat map for lack of better naming. Oh, that exists, heat map 1, 2, 3. Awesome, that worked, and I can directly just click on View Dashboard, and I'm taken to my dashboard. So you can see all of the visualizations you see here, by the way, are created using PPL. So again, you have all the existing capabilities of visualizations, but now you don't have to ever leave Discover to make even your most complex dashboard using your data. We have gauge, we have line. You can do regular search here. So yeah, so that's pretty much the quick and dirty demo of OpenSearch dashboards. And again, there are a lot of features I haven't really covered here. There's patterns that you can see quickly what are the patterns you have in your data set. Let's say I want to look at, some of these are existing features, but now also working for PPL. So I can quickly just zoom in, and again, it all works with PPL. Another simplification we have done is that in PPL, you usually have to type source equal to the search command initially, but that makes the queries less reusable. So we actually automatically appended source equal to for queries, which is why in some of the queries I was demonstrating just a while ago, let me go to the data set that we had. I'm in a different tab, that's why. There we go. So yeah, so here you can see, I actually don't mention source anywhere, but the actual query that's going to the backend has this data set I've selected as source equals to that being sent to the backend. So you don't actually even have to, you can start reusing queries like this. You can build very complex queries. As long as the structure of your data remains the same, you can quickly, analyze your data and investigate them.
You showed the example of writing the regex for parse command. Is there a way that can make a regex for?
Yeah, that's actually, so again, because I'm on a demo, it's a lot of things wrong. I intentionally didn't try to make it do that, but I have seen, I have attempted just giving it the entire schema and saying, or some example data saying, hey, can you make the command for this? And it's actually pretty good in like the more context you give it in the AI prompt, it's actually pretty good at figuring out what the actual PPL needs to be.
Including the regex.
Including the regex, yeah.
Perfect.
So yeah, any other questions? Yep.
Yeah, when you pulled up the status code, how did it know to read it as an integer versus a string?
Do you want to take that?
Yes, actually, it's automatically depend on input data.
Okay.
So actually, it's automatically in the query engine. What's the input data? If the input data is a string, you cannot do you can do the count, but you cannot do the sum.
Okay.
Yeah, actually, it's query engine handle it based on the data type.
Okay.
Yeah.
So it's just automatic.
Exactly. Yeah.
So you were actually showing a query natural language earlier
Uh-huh.
after doing some PPL.
Yeah.
But I noticed that you actually script the whole query from scratch. Is there a way to actually scope down using a PPL query maybe up front and then you query language, in natural query language later on? So you actually are working on the subset versus redefining in natural language the whole query.
So that's actually an interesting question because I haven't exactly tried what you're exactly asking for, but someone's actually tried just actually using this PPL query. You can actually say, I can just go to AI mode. This is not the data set that has AI enabled. Right, so if I take, let's say, the last query that I just ran, and I switch to AI. Now, this is actually considered the prompt for the AI mode now. Now, let's say I want to change the.
Nice. You answered my question.
Yeah. Yep.
Customers or users, the AI would be really cool, but for the dashboard is a GPU requirement, right?
So right now, I don't know the details of how the AI mode is wired up. I know it's all open source and it's available. I assume, yeah, so the thing is, this model that's we use for this demo right now is actually a fine-tuned model locally running, I think, Mistral something, right? So you can use any model as long as, the size of the model is going to depend whether you need a GPU or not. But that's independent of, OpenSearch itself and OpenSearch dashboards. Yeah.
Is there option to save prompt?
Yeah, prompt, not right now. So we actually had that thought of ourselves, like whether we should store the prompt or not. I think we took a decision to actually save the actual query only because it was more deterministic than the prompt, because you may not get the exact same query the next time you run the prompt, right? So that was the main reason we didn't save the prompt, but we are considering maybe changing that if people are like, hey, I actually want to save the prompt. One other thing we're considering is should we add them to recent queries, right? Because more often than not, you don't want to save your prompt, you want to save it as something you just ran a few seconds ago. That's where it might be more useful. So that is something we're thinking about.
I think the question, I understand if we say prompt, maybe every time you run, you consume that processing power.
Uh-huh.
But maybe
Yes.
process of this
Yep.
query. So if that's something that relates to a query, that's more.
Yeah, I think the way we're thinking about it is that we should, like if we are saving the prompt, we should also save the generated query alongside it, because the important thing about the prompt is the intent, right? So right now we already automatically, like in the recent queries, when you do an AI generated query, the generated query is automatically saved. It's just that we don't store the prompt right now, but that should not be too difficult to add later on. It's not a one-way decision. Yes.
Does the PPL get converted to calculate into an OpenSearch query in the background, or?
Yes. Not only OpenSearch DSR, it includes its own physical plan, its own execution plan. DSR kind of like a leaf node. Yeah.
But then, have you done some, like you mentioned about performance analysis, so like compare certain functions or a combination of functions that, are maybe not as optimized, or like turn into like a non-optimal query that is being run on the query basis?
It's possible. Actually, performance optimization is an ongoing process. We can always find something we can optimize. But currently, for most of the operation, we already push down to the DSR. Whatever we can, we will leveraging the reward index for the get the doc ID, also leveraging the doc value to do the aggregation. That's most of what we can. But for some example, for example, if you want to extract a field at the query time, that's not, you cannot leveraging anything. That's just the read the data, do the reg expression, and do the computation. For that query, there's not much we can optimize on. That's purely depend on computation resource. Actually, we will publish our benchmark result on OpenSearch benchmark website maybe on next week. So we actually can check this on public, the comparison because between the PPL and between the DSR, based on the standard big file query.
So is there a way to inspect what's the performance characteristics of a PPL?
If the PPL can be fully pushed down to the DSR, can leverage, let's take example. If we can fully leveraging the OpenSearch data structure, doc value, so the performance is very compatible. I think very minimum difference, 1 or 2 milliseconds, compared with the PPL and the DSR.
Yep.
So I'm seeing currently the query section
Uh-huh.
and the time filter is separate.
Yes.
Is there a workflow? Can it be included in the pre-search for the time filter?
Yeah.
Or is it separate?
So you can specify the time range in the PPL
Yep.
query as well. But for simplicity, because usually that query is actually more verbose to actually write saying time star greater than this, time less than this, it's just much easier for you to select time range or like things. So right now what we do is we just AND the operations. So we take the time and AND into the front of the query. So if you have one, it's an AND between the two. Right now there isn't a way to disable this to only use the query, but that's why feedback will help us saying, hey, that's very important. We want to do that, then we can consider.
So what happens if in the prompt, I say I want to search this count in the last 2 days?
Uh-huh.
What would happen?
So that's a good question. As of now, the PPL query generator will have last 2 days, right, as the time range filter automatically applied. There is a PR out right now that's actually going to split that to automatically also update the time range picker. So that way you won't have to worry about 2 time ranges being there consecutively. Yep. Any other questions? Yep.
How easy is it to add more visualization types in your own app?
So yeah, there's a lot of improvements coming to visualizations overall. This is actually, by the way, built pretty quickly, and all these visualization types that you're seeing here are built on top of Vega, the Vega visualization library. So now that we have support for generating Vega visualizations in Discover, it's just a matter of defining the right schema and the right properties that you want to expose. And once you have that, you have a new visualization type. So it's not that difficult. Right now, we just chose this as a subset, but it's just a matter of like, what is the visualization type you want, and then adding it.
Once you add something to our dashboard, can we edit it? How does it edit?
Yeah, that's a good one. Let me showcase that. So if I go to the dashboard that we just saw, checkout service.
The scatter plot, is it also the same thing?
Yeah, everything. Every single visualization on this dashboard is from PPL, from Discover. So if I say Edit Explorer, I'm brought back here, and you can see a scatter plot. You can change the fields. Here we just took the shipping amount and the order amount to see if there's any correlation between the two. I can flip axes over here, and then once I save this, let's say I flip axes and save, and then, yeah. And now if I go back to the dashboard, you should see your axes have flipped. Yep, go ahead.
I was looking at OpenSearch Playground. It's like a demo site for OpenSearch, right? It's slightly different from what's how do I get this?
Yeah, so right now, all of these experiences you're seeing are behind some feature flags. We do have an RFC out right now to enable this by default in 3.3. So hopefully this will become the default experience in 3.3. You can always switch back to the old one, but I think we're at a point now where this is stable enough and useful enough that we need to now enable it by default so everyone can start using it. But even today, if you want to go starting with 3.0, there are a few YAML config flags that enable inside OpenSearch dashboards to turn on the whole experience. This is all running on open source. There is no, just on EC2, we just said yarn start, and this is it. Yeah?
Yeah, it's actually, I'm not sure, did you join the previous talk? Actually, it's all the PPR will translate to the call set plan. And then we're using the call set plan to do the optimization, to give us an optimizer plan. And then we're leveraging the OpenSearch DSL data structure and the compute node to do the computation and fetch your data.
All right, looks like we have 2 more minutes. If anyone has any other questions. Cool, all right, thank you so much. Cool.